to start this next video, just a little story. I have a 13-year-old son, a eighth grader, and he enjoys his Nintendo Switch, his video games. And the other day he wanted more time, so I said, yeah, sure, you can have some more time, but on one condition, right? And that's that when you get home from school, you take care of certain chores. You take care of the dishes, and empty the garbages, right? I guess that's two conditions. But so that's what we call a conditional statement. If this, then this. If you do the dishes and take out the garbages, then you can have some more time on your video games. And that's what we're going to be exploring now. This next level of deductive reasoning is what we call working with conditional statements. Conditional statements. And so we were talking about premises. That's the given information when doing deductive reasoning. In many situations, those come in a very certain form, what we call if then statements. That's what we call conditional statements, an if then statement. The if part is what we call the hypothesis. And in a moment, I'm going to show you that we also give it the letter P. The then part of the statement is what we call the conclusion. And that's stated or represented by the letter Q. So we often say, if P, then Q. If P happens, then Q happens. This is a conditional statement. To give a really simple example of this, we can say, if, numerical example, if a number is less than 3, then it is less than 8. So you'll notice two parts of this. The if part, if a number is less than 3, and the then part, then it is less than 8. So this is the hypothesis. That's the P. And this is the conclusion. That's the Q. So we are going to start with some simple rewriting of conditional statements. Or they're going to start with a statement. What we're going to do is practice rewriting them as if-then statements. So I'm going to give you a statement. And what you're going to do is rewrite it as a conditional statement. So the first one is every public beach must have a lifeguard. So we want to rewrite this using if-then. I'll show you what this one will look like. I need it bigger than that. If a beach is public, then it must have a lifeguard, period. So again, here's the original statement. Every public beach must have a lifeguard. If we rewrite it using the if-then format, it says, if a beach is public, then it must have a lifeguard, okay? So, your turn. I'm going to give you several of these. And your job is to rewrite each of these using the if-then conditional form. Let me copy and paste several of these. So again, the first one is, you will stay in good condition if you exercise every day. The second is, no graduate credit will be counted for courses with a grade less than C. And the third is the patient will have a chance of recovering if he goes through treatment. All right. So pause the video and see if you can rewrite these using a conditional if-then statement. So what did you come up with for the first one? You will stay in good condition if you exercise every day. So this one had the word if even sort of built into it. And so maybe you wrote something like, if you exercise every day, then you will stay in good condition. If, here's the hypothesis, you exercise every day, then you will stay in good condition. Okay. What did you give for the next one? Perhaps something like this. If a course is completed with a grade less than C, then it will not earn graduate credit. Again, hypothesis, conclusion. And finally, the patient will have a chance of recovering if he goes through treatment. How about something like this? If he goes through treatment, then the patient will have a chance of recovering. So that's the idea of conditional statements. They have that form, if and then. If this, then this. If P, then Q. All right? If P, then Q. Then Q. Now, from every conditional statement, there are several, three related conditional statements that you can get by either interchanging or flipping and flopping the if and then parts or negating. What does negating mean? Not, using the word not, if something does not happen. So by using the word not and also switching the P and the Q, we can come up with some related conditional statements. And it's important to understand how these work. The new statements each have special names and they show their relationship to the original statement. So I'm going to list these three different related conditional statements. So if we always think the original looks like this, so the original conditional statement, if P, then Q. All right, we've established that. So the first one is called the converse of the original statement. So that one looks like this. If Q, how about I write all the correct letters? If Q, then P. So what do you notice there? We just flip-flopped. We reversed the Q and the P. So the thing about a converse statement is that it is not necessarily true. It may be true in some situations, but it is not always going to be true. The reason we introduce this idea is that sometimes people think that's true. Some people use invalid reasoning. They hear an original statement, but then they flip it around and think that the converse is true. And it's important to know that it is not always true. So that's what we call the converse. If Q, then P. The second, again, there are three of these. First is converse. Second is the inverse. The inverse is where we negate both statements. If not P, then not Q. And so maybe even pause and think about this. Do you think that statement is always true, or maybe true sometimes, or not at all? Pause and think about that. The inverse, if not P, then not Q, is kind of like the converse. There are some times when it may be true, but it's not necessarily true. Not necessarily true. The third is what we call the contrapositive. It's a fun word. Contrapositive. And the contrapositive statement looks like this. If not Q, then not P. Again, do the same thing you did before. Pause, see if you think that's always true, never true, maybe sometimes true. So if not Q, then not P. So we reversed the order and we negated both statements. This is true, assuming the original statement is true. So the contrapositive statement is true if the original statement is true. So let's analyze a situation. And we're going to look at these three different versions, these related conditional statements. And what we're going to do is we're going to rewrite this statement, the original statement, using the converse, the inverse, and the contrapositive, and then determine whether or not they're true or not. And we're also going to examine a Venn diagram to assess the validity of each statement. So here's the original statement that we're going to play with here. If a person lives in Maine, then the person lives in the United States. Okay. If a person lives in Maine, then the person lives in the United States. All right. In fact, let me get this all on one line. All right. So here is our original P, right? A person lives in Maine. If P, the person lives in the United States, that's our original Q. So if a person lives in Maine, then the person lives in the United States. We know that that is true. Maine is a state in the United States. So if someone lives there, then they live in the United States. Let's take a quick peek at what the Venn diagram of this might look like, just so we can get a visual representation as well. So if we view our universal set as everyone, right, just people in general, you have people who live in Maine, also live in the United States, but then you have everybody else in the world, right, other people, the complement, if you will, are the people who do not live in the United States. So they're out here. So let's first examine the converse statement. So what would the converse look like? Just for the sake of neatness. Well, you pause and see if you can write the converse first. Write the converse of our original statement. The converse would look like this. And let's minimize it so it can all fit on one line. So do you remember what the converse looks like, the order? It's if Q, then P. So it's basically flipping these two statements around. Let's read it. If a person lives in the United States, then they live in Maine. Well, is that a true statement or not? Does everyone that lives in the United States also live in Maine? No, of course not, right? We have people out here who live in the US that are not in Maine. I guess I should make that a dot, shouldn't I? So we know that is not necessarily true, right? It may be true, but in this case, it's not necessarily true. So now let's look at the inverse. Go ahead and see if you can write the inverse of this statement. I will continue. If you want to pause, pause. So the inverse looks like this. You remember the form? If not P, then not Q. So it's not flip-flopping them, it's just negating both statements. If a person does not live in Maine, then they do not live in the US. Well, is that a true statement? Well, let's think about that. People who live in Maine are in this red circle here. But a person who does not live in Maine, they could be here or they could be out here, right? So if a person does not live in Maine, then they do not live in the US. Well, they might live in the US, but they also might not live in the US. So this is not necessarily true, right? So the first one, not necessarily true. The inverse, not necessarily true also. So now let's look at the contrapositive. Go ahead and pause and see if you can rewrite that. So the contrapositive should look like this. If a person does not live in the US, then they do not live in Maine. Can we see if that's true or not? Well, look at the Venn diagram. If a person does not live in the US, well, that's talking about someone who is going to be living out here, people who do not live in the US. If they do not live in the US, then they do not live in Maine. Yes, we can draw that logical conclusion. That would be a true statement. If they're living out here, then they cannot live in Maine. So you can see from that example that a converse statement may or may not be true. An inverse statement may or may not be true. We can't know for sure. But a contrapositive statement, as long as the original statement's true, then the contrapositive will also be true. We say that a conditional statement and its contrapositive are logically equivalent. They're logically equivalent. The word equivalent in math usually means that two things have the same value, but they just look different. It's the same thing here, right? These two statements were very different. They were written differently. If a person lives in Maine, then the person lives in the United States. If a person does not live in the United States, then they do not live in Maine. Those are two different statements. But if one is true, then so is the other. And if one is false, so is the other. That's what it means for things to be logically equivalent. So let's continue then, extend this idea one more time and introduce the terminology, the word biconditional statement. So as we saw a minute ago, a conditional statement and its converse, right? The converse are not logically equivalent, right? The conditional statement, if a person lives in Maine and they live in the US, that may be true, but its converse may be false. However, sometimes both of them are true. Sometimes the original conditional statement is true and its converse is also true. When that happens, we call it a biconditional statement, and we use very specific language. We often combine the two statements using the phrase if and only if. If and only if. Okay, we combine them into a one statement, and it's a biconditional statement. So here's a good example of this using some numbers and some operations. So the original statement is this. If one of two numbers is 0, then the product of the two numbers is 0. So just to make sure you all understand what that means, if we're multiplying two numbers together and we know one of them is 0, The other one can be anything else. 0 times any number is always going to equal 0. Remember, product means times, it means multiplication. So if there are two numbers, one of them is 0, then the resulting product will be 0. That's a true statement, and that's our original statement. Now, before I continue, see if you can write the converse of that statement. Pause and see if you can write the converse of that statement. I'll keep going. The converse would look like this. If the product of two numbers is 0, then one of the two numbers is 0. Remember, the converse says if Q, then P, right? You just flip-flop the order. So let's see what this looks like if we look at an actual example. If the product of two numbers is 0, then one of the two numbers is 0. So imagine multiplying two numbers together. We don't know what they are. All we know is that the result of that multiplication is 0. Can we conclude that one of these numbers has to be 0? Is there any other way to multiply two numbers together and get 0? Unless one of them is 0? Yeah. If the product of two numbers is 0, then one of those numbers has to be 0. So you can see here that the original statement is true and the converse is true. So what we do is we can then combine those two statements together using the phrase if and only if. And you can do it in a couple different ways. One of them might look like this. The product of two numbers is 0 if and only if one of the numbers is 0. It's kind of like the statement works both ways. Here's another possible way you could write this biconditional statement. One of two given numbers is 0 if and only if the product of the two numbers is 0. So we're using both P and Q in either way, and we're saying if and only if. P, if and only if Q. That's another way to state a biconditional statement. P, if and only if Q. So that is the idea of a biconditional statement. And that is it for this video.